Greetings to you, everyone. You are welcome back to this channel. Welcome back to class. Today we are on calculation on frequency and wavelength under electromagnetic radiation or under ultraviolet visible spectroscopy. These are the calculations under this work. So, in the previous class, we discussed electromagnetic radiation such as visible light that is treated as a wave phenomenon characterized by wavelength or frequency. We also discussed wavelength as the distance between adjacent peak or trough in electromagnetic region and may be designated in meter, centimeter, or nanometer, or micrometer. Also, we discussed frequency as the number of wave cycles that travel across a fixed point per unit of time and is usually given in cycle per second or hertz. The visible wavelength cover a range from approximately 400 to 800 nanometer. So this is the image of the showing the frequency, and we can see here we have high wavelength. When we have high wavelength, we will have low frequency, as we can see here. And when we have high frequency, we will have a low wavelength. So frequency is also defined as the number of oscillations per second. So we have low wave frequency here, and we have high frequency here. And as you can see here, we have high frequency, short wavelength, low frequency, long wavelength. So this is the equation that is used to represent the frequency, which is equal to the speed of light equal to frequency lambda. Let's briefly do a calculation on it. What happens to wavelength as the frequency increases? As the frequency increases, the wavelength is inversely proportional to frequency. And as the frequency increases, wavelength decreases. As the frequency decreases, wavelength increases, and vice versa. Let's quickly do some calculation. Calculate the wavelength of photon that have a frequency of 2.7 times 10 raised to the power 11 hertz. The solution using equation of lambda equal to speed of light over frequency. This V is called no. It's a Greek word that is used to represent the frequency, which is given in hertz, and the C is representing the speed of light in meter per second. Lambda representing wavelength in meter. The speed of light is a constant, which is equal to 3 times 10 raised to the power 8 meter per second. The frequency equal to 2.7 times 10 raised to the power 11 hertz, as given from the equation. And wavelength is what we are asked to calculate. So we are asked to calculate for the wavelength, which is equal to 3 times 10 raised to the power 8 meter per second over 2.7 times 10 raised to the power 11 per second. And calculating this, we have 1.11 times 1.11 times 10 raised to the power minus 3 meter. So converting, we might decide to leave this as this, depending on how the answer comes, and we might decide to convert it to micrometer. If we want to convert it to micrometer, 1 micrometer equals to 10 raised to power minus 6 meter, and 1 meter is equal to 10 raised to power 6, vice versa. So we are converting to micrometer. Therefore, we have 10.11 times 10 raised to power minus 3 meter times 1 micrometer over 10 raised to power minus 6 meter. So the meter cross the meter, we have 1.11 times 10 raised to power minus 3 times 10 raised to power 6 from this equation. So because when 6 move to the upper side, we have it will carry a positive charge. That is why we're having it like this. And then we have 1.11 times 10 raised to power 3 micrometer. The final answer in micrometer equals to 1,110 micrometer, and in meter it is 1.11 times 10 raised to power minus 3. So, or this is another method that we can use to convert it to micrometer by doing a cross multiplication method. This cross multiplication method involves this, as 1 meter equals to 10 raised to power 6 micrometer. So, and 1.1 times 10 raised to power minus 3 that is gotten meter is equal to x. Making x the subject of the formula, we have 10 raised to power 6 micrometer times 1.11 times 10 raised to power minus 3 meter over 1 meter. So the x will give us 1 point, and the x will give us 1,110 micrometer. So doing the calculation, another calculation, let's quickly solve another calculation, which says what is the frequency or a photon that has a wavelength of 2.6 times 10 raised to power minus 9 meter. So the frequency equals to speed of light over lambda. The frequency, the lambda, and the speed of light. The speed of light equals to 10 times 10 raised to power 8. The lambda equals to 2.6 times 10 raised to power minus 9. And we have the speed of light, the frequency, the subject of the formula equals to 3 times 10 raised to power minus 8 meter per second over 2.6 times 10 raised to power 9, that is given as our wavelength from the equation in meter. The meter cancel the meter, we have 3 over 2.6 times 10 raised to power 8 minus 9, as this 9 will cross the division line to have to cross the division line. So as it's crossing the division line, it's supposed to have a minus, and minus minus, which is going to give us a plus. So we have our final answer as 1.154 times 10 raised to power 8 plus 9, which is equal to 1.154 times 10 raised to power 17 per second, or 1.154 times 10 raised to power 17 as the frequency can be given in per second or hertz. So calculation 3, what is the wavelength of a motion that has a frequency of 1282 megahertz? So before we do anything to this equation, first we have our equation as lambda equals to the speed of light over wavelength, which is equal to the wavelength, the speed, and the frequency, the speed of light and the frequency. We need to convert the megahertz to hertz first. So 1 megahertz is equal to 10 times 10 times 6 raised to power 10 raised to power 6. 1 megahertz is equal to 10 raised to power 6 hertz, and we have 82 megahertz from our equation, which is equal to 82 megahertz over 1 times 10 raised to the power 6 hertz over 1 megahertz. We are converting to hertz, and that is why it is on top here. If we are converting to megahertz, it will be vice versa. So now we are converting to hertz. So we have it as 10 raised to power 6 hertz over 1 megahertz. So, or we can make the x subject of the formula by saying if 1 megahertz is equal to 10 raised to power 6 hertz, 82 hertz will be equal to x, making x, we cross multiply it. After cross multiplication, we make x the subject of the formula, which we are going to have as 82 megahertz times 10 raised to power 3 over 1 megahertz. The megahertz will cancel megahertz, and our final answer will be 82 times 10 raised to power 6 hertz. So therefore, the lambda, after getting the hertz, after converting the frequency to hertz, then we have lambda equals to the speed of light 10 times 10 raised to power 8 per second over 82 times 10 raised to power 6 per second. So second cancel second, we have a 3 times 82, 3 over 82 times 10 raised to power 8 minus 6. As 6 we move from here to the division side. So from the denominator to numerator, over 82 times 10 raised to power 8 minus 6, which is going to give us 0.0366 times 10 raised to power 2 meter, which is equals to 3.66 times 10 raised to power minus 2 times 10 raised to power 2 meter. So 10 raised to power 2 minus 2 cancel 10 raised to power 2. We have 3.66 meter. So thank you for watching to this point. I really appreciate you. Please do like this video, subscribe to my channel. If there is any topic you want me to discuss, please feel free to discuss it. And thank you.